Hey everybody. So today I want to walk you through 13-3 radian measure. Now this is essentially just an alternate way of expressing measurements. Well, it's important because once you get to higher mathematics, degrees still are used, but once you get to the calculus level, even pre-calculus level, these types of radian measures of degrees become more and more seen. So it's important for you to be able to work both in radians and in degrees. Fortunately, it's not very difficult to work with. The basic idea is that, well, you know, a circle has 360 degrees. Well, in radians, that is just 2 pi. So 2 pi radians is equal to 360 degrees. Okay, it's a fairly simple conversion process. If you want to go from degrees to radians, you take the degree measurement and you multiply it by pi radians over 180 degrees and simplify. If you want to go from radians to degrees, well, you just kind of do it in reverse. You take your radian measurement and you multiply it by 180 degrees over pi radians. So fairly straightforward. We're going to give you a couple of examples from the homework. So let's take a look at number 7 here. So number 7, we have 150 degrees, and we want to convert it to radians. Well, if we look up above, well, you see that, okay, from degrees to radians, we multiply by, so I'm going to multiply by pi radians over 180 degrees. Okay, so now all I'm going to do now is simplify, right? So what do we got here? I have 150 over 180 degrees pi radians. You can clean it up a bit more. If you simplify the fraction, it becomes 5 over 6 pi radians. You can also express it as a decimal. And so that's approximately, let's see here, 2.62 radians. 2.62 radians. Okay, not too difficult. Going the other way, so for example, number 13, we have 11 pi over 10, and this is in radians. So we want to go from radians to degrees. Often you will know it's in radians if you're not told it's in radians because there's a pi there. Okay. Most degree measurements that have pi in it are going to be in radian terms. Okay, so to convert this one, we look up above. So if we go from radians to degrees, you multiply by 180 degrees over pi radians. So I'm going to do that. So times 180 degrees over pi radians, and just simplify. What simplifies here? The 10 divides into that, so it's just 18. The 2 pi's cancel out. And so all I have left is, 11 times 18, which is 198 degrees. And we're done already. Okay, so not too bad. All right, let's look at a couple application problems now. 19 and 27. So 19 is very similar to what you did in the previous section, except you're starting off in radian degrees. So really all you need to do is convert it to degrees and do it the same as you did before. So if we want to find cosine and sine using the unit circle definition. So if we have pi over 3 radians, well, I want to convert that. Let's convert that to degrees. So pi over 3 times 180 over pi. Well, I see stuff cancels out, and that becomes 60 degrees. Okay, so I have a 60-degree angle. So what's that going to look like? Something like this right here, right? Right there. Okay, and I'm going to drop down my triangle. Okay, and so finding my measurements now, so give me a 30, 60, 90 triangle. There's a 60 right there. That means the 30 is going to be right there. So again, 30, 60, 90 triangle, right? And we just have to figure out what is x, what is y, because that's cosine and sine. And again, well, if I remember right, let's see, 30 degrees. What's opposite 30 degrees? That's the x value, right? So that's going to be 1/2, right? If you go back to the previous lesson, that's what it is for 30, 60, 90. We look at the y, which is right here, right, up and down. Well, that's opposite the 60 degrees. And that's going to be square root of 3/2. Okay, then we check the quadrant. It's in the first quadrant, right? So we know since it's in the first quadrant, it's going to be positive and positive, right? So I don't need to change the signs. And so I'm basically done right now, right? So I know that my cosine of theta is 1/2. My sine of theta is square root of 3/2. Okay, basically the same as we did the previous section. Just with the extra step of converting it to degrees. Okay, so this should be a good review. One other application is finding the lengths of intercepted arcs. So for example, you have a circle here. You have an angle in the circle. And what you want to be able to do is find this length right here. Right? This length S right here is the length of this arc. It's not the whole circle, it's just a piece of it. So we want to find S right here. Okay, that piece of the circle that's defined by that angle. So it's very simple to do, really. The basic formula, all you need to know is that arc, S, is just the radius times the measurement of the angle in radians, okay, not degrees. This formula won't work if it's in degrees, okay? So let's look at 27. They give you a radius of 5 meters. They give you an angle of 2 pi over 3. So literally all you have to do is plug it in and work it out. So S is going to be equal to, what do we have here? R is 5. Theta is 2 pi over 3. Great. And you can just plug that into your calculator, work it out. So let's see, if I do it by hand, it's what? 10 over 3 pi square meters. It's in meters. Or you can turn it into decimal form and work it out there. That's going to be approximately equal to about 10.5 square meters. Okay, so that's about it. So this one's pretty straightforward. I think 19 is the toughest one, but again, that's just kind of a review from the previous one. Make sure you're able to go back and forth between radians and degrees. Also, don't forget to remember to change the mode in your calculator to the right measurement, because we're going to be switching back and forth more and more now. So whenever you try to calculate a sine, or cosine, or tangent value on your calculator, make sure you hit that mode button and check to see, well, is it in degree or radian mode? Make sure you're in the right one, or you're going to get the wrong number out of it. Okay? So thanks a lot, guys, and I'll talk to you later.